Hello, Luke. Welcome to Lesson 58. So today we're going to be talking about percent word problems. All right, and we've done some of these before. We're kind of more or less reviewing today, but just emphasizing how important it is to draw diagrams and to really think about these problems before you start the calculation process. All right, so let's go ahead and just take a problem and we'll work this one out, and then we'll talk about kind of a methodology that we're going to follow here, and we'll write down some steps that we'll use for all of these problems. All right, so let's take this first one. After market day, Joe had only 75 cows left. If he began with 150 cows, what percent of his herd remains? All right, so the very first step for all of these problems is always going to be to draw the diagram. And remember, the diagram takes the form of two bubbles, right? So we start with one bubble, and we refer to this one as the before bubble. Other times you might think of it as the 100% bubble. All right? This is always the bubble that will contain the original amount, the amount that we started with. All right. And then from there, we go on to the second bubble. And the second bubble could either be one of these, right? Kind of the double bubbles that we've seen before, or a single bubble. All right. And the double bubble just indicates that the original amount is growing. It's not staying the same. It's not getting smaller. It's actually getting bigger. And that's why we kind of show that with the double bubble indicating, growth. The other form of the bubble is just the same circle, but then we divide that up into two sections. So we're kind of cutting up the circle into two parts. Okay, and one of those parts generally is the part that we're looking for in the problem. All right, so that's all review, but let's just make sure we are doing that first of all, and second of all, that we can use the same process for this problem. So again, the first step, draw our before bubble. That's never going to change. It's always going to look like this. The second part of this diagram, though, is to figure out whether this is a double bubble or a single bubble. Are we growing or are we staying the same? So let's take a look at what we have. The problem states that Joe had 75 cows left. So that would indicate that's what he has now, not what he had before. If he began with 150 cows, there we go. So 150 cows is what he began with, and he's ending with 75 cows. So it's pretty clear in this case that we are not growing. The number of cows is actually decreased. So this bubble is not going to be the double bubble. It's going to be the single bubble. And anytime it's the single bubble, we're going to divide that up. We're going to take a part of that bubble. Or we could say there's two parts to that bubble. So we're taking the original amount and we're dividing it into two groups. The first group is going to contain some number. We'll just call it, maybe number 1. All right. And that's going to be equal to some percent. Okay. And then we have our second number. We're going to call it number 2. And that's going to be equal to some percent. We don't know what yet. Okay, this is kind of the generic form for any one of these problems where the bubble is not growing. So without even reading the problem, as long as we know that it's not growing, we can write this diagram. Okay, that's always step number 1. Maybe I'll even put that out here. Step number 1 right here. Okay. Now, the second step is to try to fill in these bubbles with all the information that they've given us. Okay, and each problem is going to be different. It's going to give us different pieces of the puzzle. So we need to go through the problem, pull out the information, and put it in the right spot in the diagram. So let's take a look. After market day, Joe had only 75 cows left. So that definitely doesn't belong in the before bubble. That's in the after bubble. And 75 is not a percentage. So it's not going to be one of these percents. It is an actual number. And so that's going to be one of these numbers. It could be number 1. It could be number 2. We don't really care which one it is. It doesn't really matter at this point. So let's just substitute it in for maybe number 1. And maybe just to show this, we'll just say 75 cows. Maybe I'll just box it, and I'll just write in red 75 here. That's one of our numbers, okay? And then it says, if he began with 150 cows. So what's the 150? That is the original amount. So that goes in the before bubble, the 100% bubble. Okay, we're dealing with 150 cows in the beginning. Okay, so that's where that number comes from. So now we have 2 things figured out. We still have these 2 percentages to figure out, and we still have this number 2 to figure out. Okay, then they ask what percent of his herd remains, which we won't even worry about that question yet. Right now, we're just kind of pulling information out of the problem. So at this point, we've pulled out all the numbers that we could from the problem. So now we have to use our mathematical tools to discover what these other unknowns are. So we have to discover what this percentage is, what this percentage is, and what this number is. 3 things that we need to fill in for this diagram. So if we know that this second bubble still contains everything in the first bubble, we're just dividing it up into 2 parts, one part being the 75 part, that would mean that this other part of the circle, this N2, would have to represent the rest of the 150, right? Because this bubble, again, should contain the same amount as it had before. It's just we're dividing it into 2 groups. All right, so that helps us because then we know that if I take the 150 and I subtract from that the 75, that's going to tell me how many cows are left over in this bubble. And in this case, it's actually right on the half mark, right? So the second number here is actually 75 again. I'll just write it in blue this time. All right, so that's 75. That came from here. Okay, and again, these 2 75s, these 2 numbers, have to add up to the original number, and they do, so that's great. Okay, now we have to figure out the percentages. So this is where we have to actually use an equation. So this is the before, so we're asking 75 is equal to what percent of the original? Okay, and I know in the textbook, they even, just to clarify this, they'll even write into the original bubble the little of right here, just so that when we think in terms of equations, we remember that this is the of part of the equation. So we have what number is equal to what percent of 150. And maybe I'll just write that. We know the number. What number, 75, is equal to what percent? Maybe I'll just do the WP to represent this percent right here. What percent of 150? And as I've told you before, in mathematics, almost always, the of will represent multiplication. Almost every single time, the of will represent multiplication. When you're reading a story problem, you see the word of, you can almost always just replace it with a multiplication sign. All right, and when we have these equations, that's exactly what we need to do. So knowing that, I could even rewrite this as 75 is equal to what percent times 150. Okay. And now we see that we have an equation. And it's in one unknown. The unknown is the WP. Okay, so we can solve for that. And how do we do it? Well, we divide both sides by 150. And if we do that, if we take the 75 divided by 150, we're going to end up with 0.5. I won't do the math on the page here. You'll just have to trust me that 75 divided by 150 is 0.5, and that's going to equal the what percent. Okay? Now the last step here is notice I did not take this in the book. Sometimes they write 1% as what percent over 100, which is fine. They're just emphasizing that that is a percentage. Sometimes just to clean the problem up a little bit, I will leave that part out and just know that in the end, I have to change this decimal to a percentage. Okay, and whenever you change a decimal to a percentage, all you do is move it over 2 decimal places. So if I have 0.5 and I'm trying to turn that into a percent, I simply move the decimal over once, twice to the right, and it becomes 50%. Okay, so just to clarify, if I have 6.75, I would move it over twice, and that becomes 675%. If I have just the number 3, well, the hidden decimal is right here. I move it over twice, I'm going to have a 300%. If I have 0.3, it'll be, move it over twice. It's 30%. Okay? So just kind of bear that in mind. That's what I'm doing here. I'm just kind of saving myself having to write what WP divided by 100. And you can certainly do this too. Kind of change it to the percent at the very end. All right, so this would mean, therefore, that WP is equal to 0.5, but I have to change that 0.5 into a percent. Don't forget to do that. And that's going to be 50%. All right, now if you don't follow me with that, think about it and maybe pause the video and tinker with it a little bit and make sure that that makes sense to you. And don't forget to do this. It's not 0.5%, it's 50%. If you continue to forget that it's 50%, well, then in the equation in the very beginning, maybe it would be easier for you to just write the WP over 100 right away to indicate that this is a percentage. It's something over 100. Okay, and if you do that, you'll still end up with 50. You just won't have to move the decimal like I had to here. Okay, so bottom line, this percentage here for the 75, that is going to equal, 50%. 50%. And if this is 50%, well, then the other one has to be 50% in this case, right? Because together they have to add up to 100%. And so I have 50% here. Well, that would mean that there is 50% in the other one as well. Okay? So at the end of the day, the goal is to fill out this diagram, which now we have been able to do. And then the last part to these problems is simply to answer the question. And the question is, what percent of his herd remains? Okay? And what did they say? 75 cows were left. That's how many remained. So we look at the 75, and that is equal to what percent? 50. So the answer is 50% remain. Okay? All right, so we've been doing problems like this before. We're just kind of emphasizing, though, the importance of using these diagrams. And so below this, I want you to take out your math notebook and write these in here, okay? Maybe title the page percent word problems, and then draw or write in these steps. And if you want to, create an image or a diagram of these bubbles, kind of showing the two different kinds. Maybe draw a diagram of the first bubble and the second bubble being the same size, and then another diagram showing the first bubble and the second bubble being, a double bubble, just so that you remember what we're talking about. But in both cases, these are the steps that you're going to use to solve it. So the first step is simply to decide if the original amount is growing or are we taking a part of it. All right? Remember, all we're doing there is deciding if we're going to use a double bubble or a divided bubble for the second one in the diagram. Okay? The second step is to draw the before and after bubbles. Boom. We draw the before and after. That's easy. Then we fill in the bubbles with the information that is given in the problem. That's where the 150 came from, and this first red 75. Then we have to solve for the unknowns in the bubble, and that's where we have to use our head and try to decipher how we're going to solve for the unknown parts of the puzzle in the diagram. All right. And then lastly, we answer the problem once the bubbles are filled. So once we have all the unknowns filled, we can go back, look at the problem, and decide which part of this diagram are they interested in. And then that is going to be our solution. All right? So very good. So if you need to, pause the video, get this written down in your notebook, and then we will continue to the next problem. All right, so here we go. Rob earned $223 this week. He decided he wanted to give 10% to the church. How much did Rob give? Oh, there should be a 2 there. Well, I guess it works either way. How much did Rob give the church? Okay, so I'm going to have you try this on your own. Make sure you have those steps that we talked about a minute ago, and put those right down in front of you. Here, I'll even paste them right on the screen here for you. And I want you to try to do this on your own first. And then we'll do it together and see how well you did. All right, so let's give this one a whirl. To begin with, we will just take it one step at a time. So the first step, decide if the original amount is growing or are we taking a part of it. So he earned $223 this week, and he decided he wanted to give 10% to the church. So we have to kind of understand what's going on. He has $223, and he's giving away some of that to the church. So he began with $223. He's going to end with something less than that. So we're definitely not growing the original amount. We're taking a part of the original amount. So that would indicate that our bubbles are going to be the first one, which is always the same. That's just the original. That's the before. Or we could say the 100%. And then our second bubble is not going to be a double bubble. Our second bubble is going to be a divided bubble. Okay, so we've got that listed out. Now, each of these is always going to have an equal sign in it. And on one side, we're going to have a percentage. And then on the other side, we're going to have a number, some number. We'll call it number 1, number 2. Maybe we'll call this one over here number 0, because that will also have a number. All right, so that's just kind of the general layout of my diagram. Now I can start filling it in. So Rob earned $223 this week. That's his original amount. So I can replace this 0 number, or this number 0, with 223. So maybe we'll just highlight that and say it's 223. Now, he decided he wanted to give 10%. Now, notice here, they're giving us a percentage, not a number like they did last time. So we're going to replace one of these. It doesn't matter which, but we're going to replace one of these percentages with 10%. Okay? And that's all they give us. So the rest we need to figure out. So here, what are we going to do? Well, I can't really figure out what number 1 or number 2 is. Well, at least I'm not going to quite yet. Let's look at this percentage. We could figure that out very easily. If this is 10%, well, then this percent has to be the rest of it. And so if the 100% is total, then this bottom number has to be, or this bottom percentage, I should say, has to be 90%, right? Because they have to add up to 100. So that's easy. Let's just get that out of the way. Now, to figure out number 1 and number 2, we need to actually set up some equations. So we know that number 1 is equal to, because that's what it says here, number 1 is equal to the 10%. And then remember, I could have actually written this in here. There's an of right here. So number 1 is equal to 10% of, meaning multiply, 223. Right? Following me here? So that is our equation. Now we can actually solve this, and this is going to be really easy. First, we're going to take this 10% and change it into a decimal. What's the decimal form of 10%? It's 0.10, right? Remember we just talked about how to change a decimal into a percent. Well, changing a percent into a decimal, we do the opposite. We just move the decimal point 2 places to the left instead of to the right. So we end up with 0.10, and we're multiplying that by 223. Well, that's going to be 22.3. So N1 is equal to 22.3. Now we're dealing with, maybe I should have written that here. We're dealing with money. So this is actually $22.30. And this would go next to the 10% because that was our equation. So we have, I'll put it in blue, $22.30. Hopefully you can see my decimal point there. Decimal point, $22.30. All right. Now, what's number 2? Well, we could set this up as an equation. We could write it all out as N2 is equal to this 90% times, meaning the of 223 times 223. And we could multiply that out. That's fine. That's one way to find out what N2 is equal to. Or we could just say, well, we need to have 223 total. And we know that 2230 has already been used in the top part of the bubble. So the bottom part of the bubble must contain everything else. So we could just take $223 and subtract the $22.30 from that. That would certainly be another way that we could solve this. Either one of these approaches is totally legitimate, and it really depends on you which way you think is easier. So since I have this one already partially written out, we'll go ahead and just do this one. So we have, whoops, what am I doing? $7,002,000.70. Okay, so this number 2 we can replace with $200.70. And now we've completed our bubble. Everything in the bubble is complete now. Now we can go back to the original question and just try to figure out what part of this diagram they're interested in. So if he earned $223 this week, he decided he wanted to give 10% to the church. How much did Rob give to the church? So we're asking, what is the 10%? That's the one we're interested in. He gave the 10%. How much money was that? And to know that, we look at our diagram, and the answer is $22.30. So he gave $22.30 to the church. Boom. There it is. All right. So hopefully that makes sense to you. If it doesn't, pause the video, go back, look at it again, maybe even try it on your own again until it makes sense. But hopefully you got that right the first try. All right, let's move on. We're going to go to another problem here. And again, pause the video, try this one on your own. I'll put the steps here as well. And give it a whirl. All right, so let's look at the problem. This year, Jack and Jill hauled 400 buckets of water. This is 60% more than they hauled last year. How many did they haul last year? All right, so what is the original amount here, or kind of the starting point? Oops, the starting amount. Because remember, we're going to have a first bubble here, so we'll go the before, or the 100%. And maybe this time I'll remember to put this little oven here. And then we can try to decide if this is a double bubble or a single bubble, or a divided bubble, right? So what's happening? Well, this year, Jack and Jill hauled 400 buckets of water. This is 60% more than they hauled last year. How many did they haul last year? So what's the original amount? And we usually refer to, the first amount, the before. That's why we say before here. And in this case, they don't tell us what the before number is. That's kind of the question that they're asking. They want to know, how many did they haul last year? Well, that would have been the original amount, and then this year they hauled 60% more than that, which is 400 buckets. Okay, so what we don't know here is actually the original amount. All right, but we do know that the original amount started last year, and then this year there is 60% more than the original amount. So the key is more than, the 60% more than. So that indicates to us that the next bubble is actually going to be one of these double bubbles, okay? Because it's indicating growth. We started with something last year, and then we increased by 60%, and now we have 400. So since we increased, we have a double bubble for our after bubble. Okay? So hopefully you understand how I got that. Now we have to think about what the numbers are going to be. So this one is not like the divided bubble. This one just has a number. We'll call it number 1. And the number is equal to some percentage. Okay? It's pretty much that simple. So there we have kind of everything laid out. Now let's try filling in some things with numbers. So this year, Jack and Jill hauled 400 buckets of water. Well, this year is the after year. So that's the amount. That's a number. It's not a percent. It's a number. They hauled 400 buckets. So that would indicate that this number we can erase and instead put 400. Okay? Now, this is 60% more than. Now, be careful with this. This is where it gets a little bit tricky, and it's where a lot of people make mistakes. This is 60% more. Okay? So, if I just took this at face value and just plugged in and said, oh, there's my percent. This 400 is 60% more. And I write in here, oh, 400 must be 60%. All right, do the smell test here. Does this look right? Okay, think about it for a second. We've said that it's growing. It's getting bigger. So what this equation is telling us is that 400, which is the only number going to be in the second bubble. So this 400 would include everything in the second bubble. 400 is 60% of the original amount. Now think about that. If 400 is 60% of the original amount, well, then that would mean that 400 is actually smaller than the original amount. It's not even 100% of the original amount. If it were 100% of the original amount, it'd be the same as the original amount. But in this case, it's only 60% of the original amount, which would mean it's less than the original amount. But that doesn't make sense because we've both decided that this bubble should be a double bubble because it is growing. And if 400 is 60%, clearly it's not growing. It's getting smaller. It doesn't even include the full 100%. So right away, you should see that there is something wrong with the way this is written. When you have the double bubble, this percentage should, maybe I'll even write that, this percentage should always be greater than 100%. Because we're growing. It has to be greater than 100% if we have a double bubble. Obviously, if it's a divided bubble, it's not. But if we have a double bubble, this percentage always has to be greater than 100%. So, what went wrong here? Well, the part that went wrong is the way it's written, it's a little confusing. It says, this is 60% more than. Well, that would mean that it is the 100%, and it's 60% more than the 100%. So if it's 60% more than the 100%, then the grand total in terms of percentages is 160%. Now make sure you understand that. 160% because we have the original 100%, but then we're also adding to that 60% more. And 100 plus 60 is 160%. All right, do you see how that works? Okay, then we're clear to move on here. So the only unknown in this case is this guy right here. We're going to call it number 0 again. Okay, everything else we've figured out. This is the only unknown. So let's write this out as an equation. So we know that 400 is equal to 160%. Now I'm just going to, well, all right, I'll write it as a percent to start. 160% of, meaning multiply, n0. Okay? Now, 160% can be written as 1.6, correct? If I change that percentage into a decimal, times n0, 400. Okay, now I can divide both sides by 1.6, excuse me, to get this by itself. And these 1.6s are going to cross out. We're going to end up with n to the 0 or n0, and then we have 400 divided by 1.6. And if I'll just do that separately here to save some time, is 250. So 250 is equal to this n0. Now I keep saying n0. If we're going to write these this way, and you don't have to, you can use any form you want, I should really read it correctly. This would be read as n sub 0. N sub 0. So if you hear me say n sub 0, that's what I'm referring to, just kind of this format of writing. So n sub 0 is going to be equal to 250. All right, so we can replace that. So n sub 0 is equal to 250. So let's go back up now and just look at what they wanted to know. They wanted to know how many did they haul last year. Well, here we go. Last year would be the before, and that is 250. So they hauled 250 last year. Now they hauled 60% more this year, and that means they hauled 400 this year. Last year they hauled 250. Okay? Excellent. All right, let's try one more, and then I think that should be about it. So why don't you go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so the first step is to create our diagrams. So we know our first circle always looks the same. So we have our bubble here. This is the before, and it's otherwise known as the 100%. There's an of right here. And then our second bubble, we have to decide whether it's a divided bubble or a double bubble. So let's read the problem. Davy had 36 baseball cards in his collection at the beginning of the year. By the end of the year, his collection had increased by 150%. How many baseball cards were in his collection by the end of the year? All right, so what did he start with? Where's the before? The original 100%. Well, that's pretty clear. It's the 36. Right? That's where he started. He started with 36, and then by the end of the year, it has increased by 150. It increased by 150. So since it's increased, we will be using the double bubble, right? So how are we doing so far? You getting it right so far? Good. All right, so let's keep going. Now, in this double bubble, we're going to have some numbers. Let's just lay out the first bubble too. There's going to be n sub 0 here. That's our first number. Then we have n sub 1 right here, which is going to be equal to some percent. And remember, that percent is going to be greater than 100% because this is growing. Okay? All right, so now let's look at the problem and try to plug in some numbers. So Davy had 36 baseball cards. That was the original amount. So we can replace the n sub 0 with 36. Okay, and then our second bubble, it says that his collection had increased by 150%. So they're giving us a percentage here, not a number. So that should clue you in to the fact that we won't know what this n sub 1 is. We don't know the number. Instead, they gave us the percent. Okay, now once again, watch out for this percent. Think about what the problem's saying. It's saying by the end of the year, his collection had increased by 150%. That means it started at something and then it went up 150%. And of course, it started at 100%. Okay? That's always where you start. You always start with 100%. And then it went up an additional 150%. So once again, don't just replace this percentage with 150. Even though in this case, more so than the last problem, you may be fooled into thinking that this would be correct because you're thinking, well, it is greater than 100%, so therefore it must be right. No, it's not right. This is wrong. Okay? And it's wrong because it increased by 150%. It started with 100% and then it increased. It went up 150%. Okay? So that means its new percentage is 250%. Okay? Make sure this part is clear in your mind because that is where you will make the mistakes if you're not careful. All right? So, in this double bubble, the percentage that we're looking for is actually 250%. All right, and now we have our equation. So we have n sub 1 is equal to 250, which I'm going to write as 2.5 because I'm changing it into a decimal, times, which comes from the of, 36. So what's 2.5 times 36? It is 90. So n sub 1 is equal to 90. That is this guy. So we can replace him with a 90. All right, so what do they want to know? They want to know how many baseball cards were in his collection by the end of the year. Well, this is the before, this is the after, this is the end of the year, this is the beginning of the year. So, end of the year, how many baseball cards did he have? 90. He had 90 baseball cards in his collection. Very good. That would be our solution. All right. So hopefully you got that right. If not, go back. Maybe try to do it on your own again, and then maybe even watch this part of the video one more time. Just make sure you understand how we got to that solution. And if you can do all three of these problems, this one and this one, the 400 buckets of water, and then this one with the divided bubble, you've pretty much got it made. I mean, it's pretty much, I mean, all the problems are going to be one of those, well, actually one of these four forms. It could be in this form as well. But if you can do these, you should be in good shape to do well in your seat work. So we will stop here, and I will see you tomorrow. Good luck.